Hello. In this video, we're going to be looking at how the animation speed, or FPS, of a matplotlib plot can be improved by implementing various features. So for example, the standard way that someone might use animated plots would be to call this function animation, and we can see that by changing some of the options, most notably using blitting, we can get a much faster animation. Here we go from around 8 frames a second to around 60 frames a second. So that is around 10 to 12 times improvement on the default way to plot it. However, as we'll see as we go through the video, you will notice that this doesn't come free. There are some drawbacks associated with it. Most notably, you lose the ability to update the titles. So let's start off by looking at just a small piece of code. So for example, if you have some code here that generates a plot, we can go ahead and plot that. Now, what happens if we want to make an animation out of this plot, and in particular animation in which we plot every single point being drawn sequentially? Well, the default thing we can do for that is we can do something like this. And this may be the way that you first learn to do it. So you would literally create a for loop that goes over all the points in the data, and then you would create a loop to loop over every point in the data, and then at every point in the loop you would completely clear the plot and replot it, add some small delay between them so that it gives the matplotlib time to plot, and then you would get something like this. As you can see, the frame rate on this isn't great, averaging here around 7 FPS. So not very ideal, but it's doing exactly what we want. It's plotting every single new point here. So as you see, N at the top is detailing the number of points that have been plotted. And on the right, we have a plot of the frame time. So how many milliseconds it took between consecutive frames being drawn. And the average frame time there is around 145 milliseconds, which is around 7 FPS. A slightly better way to do this maybe to implement something like this, where instead of clearing the plot during every frame call, what we do is we simply set the data to be something new, and then we update the limits automatically, or tell matplotlib to update the limits automatically. When we go ahead and run that, we can see now the average frame time has dropped quite a bit to around 74, 73 milliseconds, which gives us an FPS of closer to 14, up to around 15. So this is a massive improvement over the 7 to 8 FPS that we've just seen. We can go ahead and plot those both together to see how one is much faster than the other. And as we can see, they're doing the exact same thing. So they're both updating the number N. They're both reflecting the current FPS and the current frame time and average frame time, plotting the exact same data, but with the frame time at least half of the naive way of doing it, or the complete replot way of doing it, you get an FPS around twice as large. So that's very nice. Now this is a nice way of doing it, and perhaps everyone can do this, but it does come with a problem, is that when you go ahead and click close on the plot, the terminal hangs because there's no way to signal that the plot has been closed. There's no event handling. The standard way that matplotlib likes animations being generated is to use the function animation, or at least some component of the animation library, whether it be timed animation or function animation, or subclassing the animation class itself. But in the function animation case, what it does, you give it a function, and the function describes how the plot should be updated, and then the animation function will go over all the required frames, calling that update function for every frame and passing it any arguments that you want, as well as a frame variable which you give it. And here what we're basically doing is we're just doing the same thing where we set the data during every update. If we go ahead and plot that, we see that it doesn't actually update on the left, and that's because even though we've told it that the data is updating and the title is updating, the axes do not update. So even though the FPS is an improvement on the previous case, we're not actually getting any data being replotted. The way that we sort that is to, in the update function, every time the update function is called, we auto scale the view and reset the limits, which gives us our same animation as before, with only a slight increase in FPS over the naive case, in which we completely redrew the plot, and not as fast as the partial replot case, in which we basically did the same thing. So something's happening there behind the scenes. That means it's plotting slowly. And before I continue, I should just say that this would be suitable for instance if you had some data where you literally wanted to plot every time the data came in, you wanted to update the plot. Or you just want the smoothest plot possible, so the highest FPS possible. And you're not necessarily limited to just adding one data point on the plot at a time. You could do it so you can have several points at a time, but the idea is the higher the FPS, the smoother it looks. Now, what can we do to improve this? Well, let's see what we've got here. So here, what we do is we have the same situation as before where we're updating the data, but now we're not always auto-scaling the axes and replotting the axes. What we're doing is we're looking to see if the data exceeded the bounds at any point. We then go ahead and add on a finite amount to each of those bounds in the appropriate position where the data exceeded it. And then we signal a flag that says, okay, yes, some of the data has changed, some of the axes have changed, go ahead and rescale the axes. So what we see here is we have a low value for the frame time of around 60 milliseconds. And then we get the odd spike whenever the data exceeds one of the axes. So watch for the spike. And there we go. So the frame time jumps from 60 to 120. And we can see that that now fits between our previous two plots. So it's around 15 FPS when not doing anything with the axes, and then around 8 FPS when doing something with the axes. So it's oscillating between the two. It's only taking a long time to redraw the axes when needed, but it does lead to a sort of jumpy behaviour. And if we plot the direct comparison between these two, we can see how they fare. So here, where we're updating and rescaling the axes every single frame, we're hovering around 120 FPS. But where we only rescale and replot the axes when needed, you see that we get the 120 FPS spikes, which don't occur very frequently. So what we end up with is a much faster plot overall. So going from 8 FPS to 15 FPS. And we still have everything else updates, such as the title, in real time. Now, how can we improve on that? So the way you would normally improve on that is to use something called blitting. So if I go ahead and show you an example of blitting, what blitting basically does is rather than just call a function every time it wants to update the frames, it calls the function, which then must return which elements on the axes were changed. And then it will only change those elements that you said were changed. So we need to give it a list of everything that we change, which in our case is the two titles and the two lots of data. If I go ahead and do the normal blitting, you see we have a situation like we had before where nothing is being updated. So again, this is because the axes are not being told to update. It doesn't do it automatically. But also now the titles are not updating, despite the fact we explicitly wrote here to update the titles. But what we do see is that this line does update because I pre-allocated these axes, whereas on the left the axes are not pre-allocated. So when the axes are pre-allocated, you can see that the blitting really helps. So now we're down to around 18 milliseconds per frame, which is in excess of 50 FPS, closer to 60. So what do we need to do to be able to reflect our axes updates? Well, the first thing we could do is we could implement the same code as before, in which we check if the data exceeds any of the boundaries and then add a small increment to each of those boundaries, only when required, and then rescale the plot during those instances. When we do that, we can see we get really good performance. So we hover around 18 milliseconds per frame and only jump up to around 80 milliseconds per frame whenever the axes are rescaled. So it's a much larger average frame rate when compared to not blitting. But if I run this again, you will see that the title now only ever updates when the axes are updated, because we said that when the axes need to be updated only when the data goes outside the axis. If we say the title needs to change every single frame, then we'd be left with the situation where we're hovering around the 80 millisecond mark again. So we wouldn't necessarily be any faster. Blitting is not a complete solution to speeding up the plot. You have to accept some drawbacks, such as the axe titles will not be updated, even though in this update function here, we do update the title. That is not reflected unless this fig.canvas.draw is applied. And when that is applied, we have large spikes. We want to keep those spikes down as much as possible. So what does all that look like together? So on the left, we have our no blitting. So the top one is where we're using our fig.canvas.draw every single time with the auto scale, resulting in around 8 FPS. We can improve that to around 16 FPS by only auto scaling and redrawing whenever the axes change, which we said was when the data exceeded the axes. The advantage of doing it like this is that we still get updates for the titles. So the titles will still always update even if the data is not touching the axes. On the right, we can see what happens when we use blitting. If I go ahead and play this again. So we can see that when using blitting, when the axes are predefined, the animation runs very, very smoothly and very consistently. However, axes are not redrawn, so these are not redrawn during blitting, and neither are titles updated even if requested. The way that we solved that was to add some intelligent feature, which basically says whenever the data exceeds the frame, we go ahead and redraw the axes, which then also triggers an update of the titles. So if you notice here, the title is only updating when the data exceeds the end. And as you see here, we get the small, very low value for frame time here, which leads to a high value of FPS, which is around over 60 FPS, around 65 FPS. And then we have the occasional spike anytime we need to redraw. And so really the blitting, you can think of it as a compromise. If you know your axes, and you just want to plot your data, it gives you very, very high frame rates compared to just the normal way of doing it, in which you auto scale every frame. Without blitting, which is around 10 FPS, it's around 6 to 7 times faster. If you need to update the axes, you need to do something a bit more intelligent, either periodically update the axes to reflect any new data coming in, or if you need the titles changing. So that's something to think about when thinking about blitting. So I hope you found this video interesting. I thought it was quite interesting to see how the different improvements can be made. Really, the improvement from just going from the standard function animation to intelligently updating the plot, I thought was quite a good one. It's a nice FPS increase, but really blitting is the way to go forward if you need the high FPS. If you need higher, even higher FPS, if you find that you've got very complicated plots that aren't producing the FPS required, typically what I do is I would save every single frame from the animation and then go ahead and write it to a movie file or an animated GIF. Alternatively, matplotlib does come with the FFmpeg writer, so you can write animated GIFs and MP4 movies directly. But for something like streaming data from real-time sensors, the FPS can make a very large difference to how perceptually good that looks. I always try to get the largest FPS possible. One little hack you could do if you're really concerned about the titles not updating every single frame, you can create a text object within the plot window itself, and that will be reflected in the plot update. So that's one way to hack it, but you just need to be careful about how you define the position of the label, especially if these axes start to change. So good, I hope you've enjoyed this video. I know it's quite a quick one. I think it's quite nice just to see how an improvement can be made to the standard way of plotting in matplotlib. Thanks for watching.